San Francisco Bay is one of the largest estuaries on the west coast of North America. It's a vital ecosystem where the rivers meet the sea, but it's also been severely impacted by human activity since the time of the gold rush. One of the pollutants that came with the gold rush was mercury. Today, the legacy of mercury pollution is still adversely impacting the estuary, and a major focus of my research is understanding how mercury gets into the food chain. Perhaps you've been out to San Francisco Bay and have seen the fish consumption advisories in multiple languages. They caution people to limit the amount of fish they eat out of San Francisco Bay. The advisories are particularly important for pregnant women because mercury can harm the nervous system of the developing baby. Much of the mercury that's in fish today originated with the gold rush. Each gold miner carried a 76-pound flask of mercury high into the Sierra Nevada mountains. The use of mercury made it possible to capture and recover the tiny gold flecks that could not have been easily recovered by hand. But in doing so, 10,000 tons of mercury were spilled in the Sierra Nevada mountains. The gold rush was made possible by mercury. And what was the source of that mercury? It was mined up and down the California coast in the form of a red rock called cinnabar. Today, those abandoned mercury mines are ongoing sources of mercury. So there's really two historic sources of mercury: the abandoned mercury mines themselves, and there are hundreds of them up and down the coast, and the mercury that was transported to the Sierra Nevada for use in gold mining. The problem is that once mercury is in the fish, it cannot be removed. The way that mercury gets into the fish is through their diet, beginning with the microscopic algae that are the base of the marine food chain. My research as a Cal-Fed postdoctoral fellow demonstrated that algae accumulate 100,000 times more mercury than is present in surrounding waters. The exact amount depends on the water chemistry, things like the amount of salt in the water and the amount of organic matter, meaning that water chemistry is really important. Well, we can't readily remove the more than 10,000 tons of mercury that we spilled in the Sierra Nevada watershed. Researchers would like to use their knowledge of the biology and chemistry of mercury to limit the amount of mercury that gets into the fish. More than 150 years after the gold rush, we have a long ways to go towards restoring the Delta and the San Francisco Bay, but an understanding of the processes by which contaminants enter the food chain will help.